Howdy, folks. Welcome back again. Rosendo from MLH here. We've got some awesome content in store for you. If you were just at the previous workshop, you learned a little bit about RAG applications using Okta FGA. Now we're going to be jumping into vector AI search with Oracle. It's going to be a really interesting workshop. If you want to get registered and checked in, make sure you hit the link at the bottom over here. I'll also be dropping it in the chat for y'all. So yeah, make sure you get registered, checked in so you can get credit for being here. On top of that, yeah, like welcome back. I'm really excited to see so many folks sticking around and really getting into the content that we have in store. So really, without any further ado, I'm going to be going ahead and introducing one of the industry experts from Oracle is going to be teaching you all about vector AI search. Please give them a warm welcome. Hi, Maria. How's it going?
Hey, how are you guys doing? Thanks so much for having me today.
No worries. All right, I'll leave you to it.
Awesome. Thank you. So, folks, what I am going to talk to you today about is AI vector search or similarity search, which is one of the components or pieces of the AI story and specifically AI RAG. So, when you think about databases, especially something like Oracle that's been around a long time, you're probably thinking that, well, it's very good at finding structured data, being able to find information like what was the revenue we made last quarter, how many pieces of this item do we have in stock, things like that. Very organized, structured data answering very specific questions. But the world of business data and just data in general has completely changed. We have a huge growth in the volume of unstructured data, social media posts, videos, images, documents. All of these different types of data also play a key role in being able to get a holistic view of our business. We might want to offer our end users the ability to upload an image of a pair of boots that they liked the look of, and they want to find similar boots on our website. And that's what I want to talk to you about today, is being able to do that similarity search when somebody says, I want you to find a product that matches this photo I've uploaded or this description I'm going to provide you. And that's what we're going to look at, because all of that ability to search unstructured data is and find matches is called vector search or similarity search. And it's going to help us get value out of all of that unstructured data, because instead of looking at that data as bytes or pixels, we're actually going to look at the meaning of that data or the semantic content of it. So what is it an image of? What's the topic of this document that I'm looking at? Who's in this video? That kind of information rather than the individual pixels. And we're able to do that by using a new data type called a vector to represent that unstructured data. So a vector is basically just a sequence of numbers or an array of numbers. Each one of those numbers is called a dimension, and those dimensions represent key features of the unstructured data. So, and I'll give you some examples of how they're built in just a minute so you can kind of get a better understanding of how this works. But just know right now that we're able to find a very easy format to represent that unstructured data that is going to make it very easy for a computer to be able to do that similarity search incredibly quickly, because we're going to represent the semantic content of the unstructured data basically as numbers in an array. Now, these arrays are built using AI deep learning models. They're called embedding models, but basically they're actually going to find all of these different attributes about the unstructured data and build these vectors. Once the vectors are built, how we find similar products, similar videos, similar documents is very simple. We're going to use a mathematical distance formula to measure the distance between these multi-dimensional arrays. And these mathematical formulas can be things like Euclidean squared, cosine, dot calculations, things like that. But basically, what is the distance between my vectors? How close are they? Vectors that are close together contain similar content. Vectors that are further apart don't have any similarities. And that's really how this is all done. You take the unstructured data, convert it into vectors, measure the distance between the vectors to find similar content. So how would you build one of these vectors? What would it look like? Well, imagine we've been given a huge backlog of support tickets. So, you've done this yourself, I'm sure, at your university, or if you've ever gone to the Genius Bar with your laptop, that you're having problems with your laptop, you need it to some help with it, you're going to supply or log a support ticket. And so imagine we have a big repository of these support tickets. We want to vectorize them. The kind of information that we would put in the vector would be things like, what product was this support ticket for? What was the severity of it? What were the symptoms that the user reported? Maybe the system was spontaneously rebooting. What's the current status of the ticket, and what was the solution, or what is the current OS that that system is now running? As you can see, each of the dimensions is going to represent a different feature about our support ticket. And as I said, they're not normally as simple as I'm showing you here. They're actually all generated using these machine learning algorithms to generate the vector. So it's a little bit more complicated than on what I'm showing you here. Typically, a vector would have hundreds, if not thousands, of dimensions in it. But you get the idea. Now, rather than trying to show you what this looks like in multi-dimensional space, let's look at vectors just using two of their dimensions. And if I pop them on a graph, the graph would look something like this. You'll notice straight away that in the upper left-hand corner of the graph, the support tickets that are about laptops running slowly are quite close together on the graph, while the support ticket about a desktop crashing is much further away on the lower right-hand corner of that graph. And so straight away, you can kind of see, if you measured the distance between those different points on the graph, that you'd be able to quickly say the two vectors in the upper right or left-hand corner are very close together. That means they're probably containing similar content. The one in the lower right-hand corner, not so similar, so therefore probably not so relevant. And really, that is the magic of similarity search and using vectors. Now, it doesn't have to be just on support tickets. I could do this for any kind of information, whether it's image information or document information, but you can see here just how the vectors would line up on a graph. So if I was looking at documents about fruit, you see all of those have kind of been clustered close together in the lower left-hand side of the graph. I had information about different states. They are in the lower right-hand side. And my animals, all the documents I had that were about animals, are towards the center of the graph. And even within that cluster or family of vectors about animals, you'll see there that kittens, lions, cats, they're closer together than dogs and wolves and puppies, right? So you can kind of get the idea of how this clustering works. And if I was to add a new document about tigers, it would appear right next to the lions and the kittens because it's part of the feline family, and that's all similar content. So now that we know what the vectors are, let's talk about how they become useful, because although it's nice to be able to find similar images online of a kitten that looks like yours, really vector search is best used when it's used in conjunction with real business data or real data that's interesting to customers. And that's what I want to talk about with you today, is about combining that ability to do vector search with business data to help solve real world problems. And that's why in our latest version of the Oracle database, we've added a new vector data type to allow you to store those vector embeddings that are generated by the embedding models or the machine learning models. You can store them right alongside the rest of your data inside in the database, and then you can use very simple SQL syntax to be able to access those vectors and do similarity search at the same time as querying the regular data. And on top of that, we've also want to accelerate the performance of these kind of queries or these kind of questions that your end users are asking. And we've done that by creating new types of indexes for vector search. And I'll explain what they look like in just a moment. But by combining vectors into an existing data store where you already have a lot of your business critical data, it means it's going to be much easier for your end users to get value from this. And of course, it means you don't have to move data around and synchronize different data stores. So hopefully a much easier solution for you if you're looking to build apps using vector search or similarity search and regular business data. So how exactly does this work? There are a couple of key elements that you want to look at. You want to look at how you go about generating vectors. That's the first thing you need. Once you've got the vector embeddings, where are you going to store them? How are you going to search them? How do you index them? And then how we integrate them with other aspects of a relational database. So let's start right at the beginning with generating vectors. This is the process, as I said, of converting all of that unstructured data, whether it's a text or an image, into a vector. And it's done using deep learning embedding models. Now, these embedding models are not something you need to build yourself. There's hundreds of them available, both as open source or commercially obtained, that you can buy these. If you happen to be lucky enough and you have access to a huge pool of data scientists, or you've got a very specific use case that you need to generate vectors for, then you may want to come up with your own embedding model. But for most of us, the open source embedding models that are available through Hugging Face and a bunch of the other vendors are just good enough for us. The question you need to ask is, which embedding model out of these hundreds of open source ones do I pick? And really, in order to answer that question, you need to know what kind of data you're going to be processing or converting into vectors, because that will help guide you. Some of the embedding models are much better at dealing with documents. Others are better at dealing with multilingual documents, so not just English ones, but ones that have a bunch of different languages. Others are much better for video. Some are better for images. We even have some folks using these embedding models to turn DNA into vectors. So, doing it picking the model will really depend on what it is you want to do with it. There isn't a one size fits all. You may need to try out a couple of different embedding models to see which is best for your particular data set and for the kind of questions you're going to be asking. So if I'm using Oracle, how do I generate vectors? What are my options? Well, first and foremost, you may already have a set of vectors. Maybe the workload you're dealing with, somebody has already vectorized all of that for you. So that's super easy. You can simply just load that vector data into the Oracle database, just like you would load any other type of structured data. You would basically just create a new column in the table that's of the new vector data type, and then load the data in. Next, you can, from the database, call out to an external embedding service that's running either in the Oracle Cloud or in anybody else's cloud, whether you want to use OpenAI or any of the other options. You can use the built-in functions inside in the Oracle database. They come as part of a PL SQL package called DBMS Vector to make that call out to an embedding model. You basically say, hey, the information in this column, in this document, I want you to vectorize that. You pass the unstructured data through the function call, it's going to return the vector for that data to you. The other option you've got is to actually bring an embedding model into the Oracle database so that your data doesn't ever go outside the database. It doesn't go to a public cloud service. So you can import one of these embedding models using the Onyx framework straight into the Oracle database. Once you've loaded it into the database, then you can simply use a very easy SQL statement that calls the vector embedding function directly from the SQL statement that basically says, hey, given this piece of data, generate a vector for me. All of that processing happens right there on the database server, and the new vector is inserted into the table automatically for you. So let's take a quick look at the different options. As I said, if you're looking to use an external provider to generate your embeddings, then you need to create a set of credentials for that. So in my case, I'm going to use OpenAI. And I've already got a username login for the OpenAI service. So I'm going to go ahead and create my credential, give it a name, and then I've put my username and password for that securely inside the database and inside that authentication parameter setting that you see there. Once I have that, then I can say the provider I want you to use is OpenAI. The credentials I'm using are my OpenAI credentials I've just created. This is the URL where you want to send my request. And this is the particular embedding model that I want you to use. And then once I've done that, it's a really simple two-line SQL statement that basically says, hey, I want to select the util to embed function. In other words, I want to run this function. I want to run it on incidents text, which is my text document for my support tickets. And I want to use these particular set of parameters. But super easy, 3 simple steps, you're already generating vectors. If, on the other hand, you don't want to do a call out to a service, you don't want to pay any money to use the OpenAI service, I get that, a lot of you are students. What you can do is you can download one of the free embedding models and using the Onyx framework, import that into the Oracle database. Again, very easy to do. This time we're going to use the same DBMS vector package. This time we're going to do the load Onyx model. You simply need to give me the model name and then the name of the file where you have it in the Onyx format so that I can load it in. Once it's been loaded in, the query gets even simpler. All I need to do is do a select vector embedding this time. So the built-in function, which model I want to use and what am I using it on? What column am I using it on? In this case, I'm using it on the incident text column inside my support incidents table. So very, very easy to be able to generate vectors inside in the database. So what does it look like to store these vectors? Now that I know how to generate them, where am I going to put them? Well, like I said, we have this new data type. So when you create a table, you simply create an extra column where you're going to store those vectors. Now you can get very complicated with this. You can tell me exactly how many dimensions you're expecting to be in each of your vectors, what the optimal format is to store the vectors. Or on the other hand, you can keep it really simple. You can just tell Oracle, I'm going to be loading a bunch of vectors. I'm not really sure how many dimensions there's going to be in them or what the optimal data type is for that particular vector. So just give me a column that will accept vectors. And that's probably the easiest approach, honestly. The reason being is the embedding models are rapidly changing right now. There's huge improvements and advancements being made here. Every week, a new version of an embedding model comes out or a brand new model totally comes out. So in order for you to be able to quickly adapt those new models, I wouldn't get into specifying all of the details. I would simply tell Oracle, hey, I want a column that's of type vector. What about getting vectors in and out? If I don't have a huge bulk load operation, I just want to insert a particular vector into a table, how would I go about doing that? It's really easy. You're going to use the standard insert statement. So insert into the given table, in my case, support instances, then tell it what values are coming in. And for the vector column, I simply say to vector, and I give it a string. I tell it it's a string, and I have the array of values or my vector dimensions inside the array there, and I can just load it in. If you want to look at a vector, now don't get me wrong, these are not that exciting to look at, but if you did want to look at a vector and see what it looked like in there, then you can do a simple select. You're going to use the from vector function. This is again built-in function that's going to convert the vector as it's stored inside the database into a string so that you can easily read it or parse it when it comes out of the database. So to vector to get it in, from vector to get it out. Let's talk about doing the similarity search though. How do you go about asking to find similar things inside in the database? And what we've done is we've made this really easy for you by introducing something called the vector distance function. Now, the vector distance function, as you can imagine, takes 2 vectors as input. So typically it's the thing you're trying to match is one of the vectors. The other vector is typically coming from a column inside in the database. So in other words, find me similar items that I've already got stored to the one that I've just given you. So in my case, it's always I like the shopping example. So given a photo of this lovely leather jacket, find me other leather jackets that you've got on your site that match this. There is an optional additional parameter that you can specify, which is what distance function you want us to use to do that calculation. Now, this is important because by default, Oracle always uses cosine to do as the distance calculation. If you've used an embedding model that's using a different distance function, and that's something you will need to be mindful of. Each embedding model does use different distance functions. When you're comparing vectors, you need to use the same distance function that was used in the embedding model. So whether that's cosine, Euclidean squared, dot, whatever it may be, you want to make sure that when you're doing the comparisons, you're using the same one that was used in the embedding model to generate those vectors. So as I said, by default, Oracle will use cosine. A lot of the more common text-based embedding algorithms will use cosine, so you don't need to specify anything here. But if you've chosen to go with a different type of model, one that maybe is using Euclidean or they're using dot, then you'll need to specify that as the extra parameter there in your vector distance function. And I'll show you how to use it in a query now, just so that you can kind of understand how this would work. If I'm looking for to do a similarity search, and let's imagine I have a new support ticket and I'm looking to see if it's similar to any previously seen support issues, so that I can maybe try the same solutions that solve those problems to solve my problem. And how I would do that is just using 4 simple lines of SQL. So I would select things like what was the solution and other information from the support tickets table. And rather than putting the vector distance in the where clause predicate, I'm going to put it in the order by clause of my SQL statement. I'm going to say, I want you to order the results of this query based on the vector distance between the incident vector column in the table and my search vector, the vector that I'm uploading as, in this case, as a bind variable to my query, but my search vector. And then you'll see it's interesting there. I don't want all of the rows in the table to be returned. I only want it to fetch the first 10 matches, or the ones that match my support ticket most closely. Why is that? Why did I have to limit it? Well, because the vector distance is not in the where clause predicate, it's in the order by clause by default. What we're asking Oracle to do is to take our input vector and compare it to all of the vectors we have in the support incidence table. So in other words, I'm going to measure the distance between my input vector and all of the vectors in the table, and then I'm going to return an ordered list with the closest vectors first, all the way down to the vector that was least similar to the one that you gave me. It works fine without the fetch first if I only have 10 rows in the table. If I've got millions or billions of rows in that table, nobody wants to see that exhausted list. I'm really only interested in the ones that are most similar to the vector that I've sent in. So I want to limit it to that top 10 matches. So as you can see, very easy to use once you get the hang of it. You're just going to put the vector distance in the order by clause, and away you go. You'll be able to start doing similarity search straight away. But the value of similarity search is enhanced an awful lot when I can combine it with other relational information, with other search criteria. Because typically, not only do I want to find the top 10 matching support instances for my particular situation, but I also want them to be from employees that are in the same office as me. And I only want to look at the ones that had a severity rating greater than 3. So in other words, I want to limit the set, not just to the ones that look similar to mine, but I want them to be from employees that are in the same office as me and ones that had a severity higher than 3. So SQL statement is now 6 lines long instead of the 4, but it's a similar thing. Pull out the columns that you want to be returned. I'm now joining my employees table to the support incidents table. I've given it the join predicate there. It happens to be on employee ID. I then put the where clause predicates on the city. So I only want the ones that are here in San Francisco with me. I only want the tickets, so severity greater than 3, and then the exact same order by with the vector distance function in it. And again, I want to limit it to the first 10 rows only. So Oracle will automatically reduce the set of vectors that we're looking at by city and by severity. We'll do the similarity search, and then we will return just the top 10 matches for that, allowing you to be able to really get a select set of similar products for what you want to answer your particular query. Now, we talked about the fact there that you are looking at all of the vectors in a table, right? And again, if you've got a small data set, that's totally fine. Doing a full table scan inside a database, even on a single CPU machine these days, is incredibly quick because we're able to process it so fast to search through that information and apply the vector. But what if I've got billions of rows? And what if those rows are quite dense? What if I've got a lot of different attribute information stored in there? I probably don't want to have to search through all of that data to do my similarity search. And for that reason, we've introduced the ability to index your vectors to be able to quickly find those similar matches on a really large data set. And we give you a couple of different types of indexes. The first one is an in-memory only index that is based on a graph. So when we're building the graph, the vectors are the nodes or the vertices on that graph, and the edges indicate the distance between those vectors. So it's incredibly quick. If I insert, have a vector, if I position it on the graph and I position it right here, it's really quick to see vector 3 and vector 2 would be closest to my query, the vector that I'm querying for. Very, very efficient. But it is in memory only. So at some point, you may exhaust the amount of DRAM that's available to you on your database environment. Now, you can, of course, scale this out using Oracle sharding or our globally distributed architecture. You can do it across rack nodes. There are ways to help increase that size, but let's imagine we've exhausted all of the memory that's available to us, and so we can't use the graph vector index. What if we wanted to still be able to index our data? Well, you can use an IVF flat index to do that instead. So if you have a huge data set, you can use IVF flat index to partition the vectors. And what we'll do is we'll break them up into sets based on their similarity. So they'll be stored in separate partitions or sets so that when your query comes in, we look to see which set it looks closest to, and then we'll just search within that set to be able to get you those similar vectors as fast as possible. Now, this type of index is persisted on disk, which means that it can be any size you have as long as you have enough storage capacity for it. And it does mean that when you've got billions and billions of vectors, that you can still access them quickly by using the index, doing the similarity search, regardless of the size. So really is an efficient way to do it if you have a very large amount of data, or if you're not fortunate enough to have a lot of memory available to you and the graph index just is too big to fit into the memory you have. So how do I create one of these vector indexes? Well, it's super easy. Looks just really like creating an index on a regular table. First and foremost, you're going to just use the new keyword vector in that create statement. So you're going to do create vector index. You tell me the name of the index, what table it's on, and which column in that table you want to build the index on. So that first line, other than the new keyword vector, looks exactly the same as what you're used to today when you create an index. Where it gets a little bit different is the next couple of lines. So next you need to tell me, what kind of index do you want? Do you want it to be one of those graph, in-memory only graph indexes, or do you want it to be the IVF or partitioned index? So you just say, use the keyword organization, and then tell me which way you want to organize it. Next, you want to tell me which kind of distance function was used to generate those vectors so that I know what I'm dealing with. Again, as I said, lots of different options here that Oracle supports, whether it's Euclidean or cosine or Hamming or dot. Doesn't matter. You'll know what it is because you'll know which distance function you used for the embedding model to generate those vectors. You just want to put this matching one right there. And then you have the option to give us target accuracy. And I'll talk about that in a little bit more detail, because it's basically when you index vectors, you're trading off performance for accuracy. Remember, you're not closing the business's books here. You're not looking for the perfect exact match. You're looking for information that's similar to what I've given you, right? So this image, this video, this document, find me similar stuff. It doesn't have to be an exact match. And therefore, we have the ability to play around with the accuracy. I really want my shoppers on my website to be able to see similar handbags to the picture they've uploaded in milliseconds. And if I happen to miss a handbag that looks similar, I'm okay with that because I've already given the user 10 options to pick from. If I'm allowing users to have that situation where I'm valuing performance and the speed at which I return the matches much more than the accuracy of the matches, then I can play around with target accuracy. And I can say, actually, I'm okay if the match is only a 70% match. I just want to return the answer quickly. If, on the other hand, I'm searching through video in order to be able to edit a movie and I'm looking for a video frame that's nearly identical to the one I'm working on so that I can splice them together, in a scenario like that, I want my target accuracy to be much higher. Maybe I want it to be 90%. Or imagine we're building a facial recognition for border control. I want to be able to check that the person coming off the plane matches their passport picture. Is this the same person? In that case, I probably want an accuracy level of 99 or 97% that this is really the same person, right? And so depending on what you're searching for, your target accuracy, you may want to set it to very, very high or very, very low, but you're trading off performance. The more accurate you want it to be, the longer it's going to take to do those matches to be sure we don't miss anything. The more relaxed you are about the target accuracy, the faster we can do those queries. So hopefully that makes sense. If it's not something you're interested in, you don't have to specify it. You can let it default. So I started to mention there, as we were looking at target accuracy, some of the use cases where we see similarity search being used. Because remember, it's not just about finding support tickets and helping me shop for more handbags and shoes and jackets and stuff like that. You can use similarity search for a whole host of different things. You can use it, as I said, to find similar documents, images, or videos to what you're working on. We see it used for biometric pattern matching, as I said, facial recognition when you come off a plane. Is this really the same person who applied for a visa or whose passport I'm looking at? You can use it to find the similar products, as I said, the ability to either type a short description or upload a photograph to a retailer and have them show you similar products. You see it also being used by retailers for product recommendation. Based on what you put in your basket or what you've been browsing, I can kind of offer you other products before you check out. I can say, hey, you looked at this stuff. I think you might be interested in this instead. It's also very powerful for anomaly detection, finding the bad egg or apple in a basket full of apples. We're seeing it being used for manufacturers, right? As the products are coming down the assembly line, they're photographed from all different angles, and those photographs are compared to the perfect product. As long as the accuracy is within a certain range, then that product is allowed to continue down the assembly line. If, however, we're not having it match tightly to the perfect product, that its similarity is found to be further away from that perfect product, then the product can be taken off the assembly line and either fixed or recycled so that it doesn't make it all the way to the consumer. Another use case that we're seeing it being used for is video editing. I mentioned that earlier on. We're seeing it being used a lot to accelerate the video editing processing for TV shows and for movies, where you've got literally millions of frames captured when you were recorded or created that movie. But now you need to edit all those different takes together, finding similar takes of the star of the movie hanging off the edge of a skyscraper. Where was the sun when that one was taken versus this one? Being able to do that similarity match between the frames, this is a great opportunity for AI vector search. But one of the things, and you've been hearing a lot about this already today, is the ability to combine vector search or similarity search with generative AI. And that has really opened up a whole new era of app dev productivity, because it's going to allow us to be able to talk to our systems and be able to get a lot of value out of generative AI, even when we're asking questions that are unique to our particular business. Because we can use AI vector search to actually improve the responses we get from generative AI, things like large language models, ChatGPT, things like that. And we do that by augmenting the prompt that we're going to send to that large language model with private data that we've got stored in our database, so that Gen AI, just for our particular session, can give a more informed answer based on our private information, so that we'll actually get a much better answer. As I said, you've heard about this already today, I'm sure. We call it retrieval augmented generation, or RAG. So let me show you how you can use vector search as part of a RAG pipeline. So what will happen is, instead of sending the end user's question directly to the large language model or Gen AI, what we'll do is we'll take their question, which in my case is very simple: why does my laptop keep rebooting? And we'll turn that into a vector. And we're going to do similarity search on that vector and all of the information we've got in the database. Now, that information would be things like other support tickets, also information about who is this user, what kind of laptop do they have, all of that information that I happen to know about that user. I'm able to extract that using similarity search on the Oracle database. And then I can combine that information along with the user's question and send that augmented prompt to the large language model, so that it has access to private data that I don't want to share with the large language model provider, but I do want to give the large language model so it can help answer this particular question. So I add that along with the user's question, I send it off to the LLM, who can then send back a very informed recommendation to that end user. And in this case, it's going to tell the end user that, hey, guess what? There's a known firmware issue with the fan that's on your laptop. If you apply this particular update while the laptop is plugged in and you're in an air-conditioned room, you can prevent that overheating and your laptop will stop rebooting. So a very informed answer versus what the LLM may have come up with on its own without all of that additional context. And the problem you get when you allow a large language model to come up with the answer all on its own without any kind of guardrails or without any augmentation to the prompt, although very convincing, that it sounds very convincing, it may be completely wrong. So using AI vector search as part of your RAG pipeline can allow you to get much better responses from those large language models. So let's take a look at what we have talked about today. I wanted to remind you that using the Oracle database, you can have a complete Gen AI pipeline. So you can have unstructured data, you can bring it into the Oracle database, have us transform that data and vectorize it and put it into the database as vectors. Once it's in the database as vectors, you can instantly begin to do similarity search on it using those very simple SQL statements that I showed you that use the vector distance function in them. But you can also leverage all of that vector information to improve your RAG pipeline by augmenting the prompts that you are sending to your large language models. So really allowing you to do the entire process. Now, we make it as easy as possible for you to do this. We've got native database APIs to do that for you. You can also do simple REST calls in and out to either embedding services or to large language models to be able to complete your RAG process. So the entire thing can be done yourself using SQL, or you can do it using our REST APIs. We also have tight integration with third-party frameworks like LangChain to make it incredibly easy for you to just code up the whole thing, never having to worry about how to do something in the Oracle database. LangChain, we have all the integration with them, all the REST APIs, so that they can easily call into an existing Oracle database and do all of that for you. In fact, one of the takeaways from our session today is a live lab where we'll show you exactly how that is. And I'll show you how to get to the labs in just a second. But I just want to remind you why we're able to do this is because we've added vector data types to the latest generation of the Oracle database, new simple SQL syntax to allow you to be able to do similarity search on those vectors, and then the new indexes to allow you to be able to speed up the access to the vector database. And as I said, super easy. You can store it alongside JSON, spatial, relational data, all there in the same database. So you can use all of them together in a single query and be able to get a really good answer for your particular application or your particular user. So where do you go and get more information? How can you try all of this stuff out that I've just showed you there? As I said, Live Labs is probably the best place to get started. You can just go to livelabs.oracle.com. There are two labs we'd love you to try out. You can start with the second one I've listed there, the AI Vector Search Basics. It'll go through everything I've showed you here in the presentation. So all the SQL that I showed you, all of the steps to generate vectors, load them into a database, query them, all of that is taken care of there in that base lab. Or you can, if you're already familiar with all of that and you want to get straight into using LangChain and building a RAG application, then you can follow the 7 easy steps that we have there where you can cut and paste all of the code that you would need in LangChain to be able to build that RAG application using the 7 easy steps to building a RAG application using LangChain. Once you've got familiar with everything in Live Labs, by the way, Live Labs will give you an environment for free that has all of the software and everything you need to run that particular lab. But when you're ready to kind of take this away and do it yourself on your own laptop, maybe offline on a different data set that you want to have yourself, then you should download the Oracle database free. This is a complete Oracle 23 AI database that's available to you as inside a container. Very quick to install, very quick to use. You just need to go to oracle.com/database/free. It's free forever. You can download it, use it as much as you like. No drama there in terms of licensing. It is completely free. You do also have a free option on the cloud as well if you want to. Unfortunately, you do need to put a credit card in, even though we don't charge you for it, but you do need one. That's why I actually prefer to use Oracle Database Free, the container, on my laptop. That way, there's no drama of having to put a credit card in if you don't want it. So with that, why don't we jump over and see whether or not there are any questions I can answer for you guys in the chat stream. I know some of my colleagues have been on Twitch and some of the other platforms allowing you to do that. So let me see if there's anything there. Oh, wow. Okay. There is a lot. All right. So, okay, there's a really good question that's come in. How does VectorDB differ from MongoDB or from Oracle? Honestly, fundamentally, what all of us are doing is pretty much the same thing. There are multiple vector databases available to you. They will all allow you to do similarity search. Where they start to differ and where Oracle differs from all of the others is the ability to combine that similarity search or the vector search with other capabilities. So you can combine it using JSON, you can combine it doing graph analysis, you can combine it with spatial data. It's giving you vector search or similarity search as part of a bigger environment that can support all sorts of different data rather than just doing similarity search. So that would be the key advantage to it. So next one was, what is an embedding model? As I said, an embedding model is a machine learning algorithm that's used to generate the vectors from the unstructured data. So it picks out the specific attributes or characteristics of the unstructured data, whether that's an image, a video, a document, and it creates that array basically of numbers that we call a vector that will represent that unstructured data for you. So as I said, the embedding models, there's hundreds of them available, mostly open source. There are some commercially available too. You just need to find the embedding model that's going to work best for the data that you're working on. So some of them are better at English documents, some of them are better at multilingual documents, others are specific for images or videos. So you pick the embedding model based on the data that you are looking to vectorize so you can do the similarity search. But the next one is, what if you want to create a vector data set and we have to use an LLM? What Maria is saying. Okay, so what if you want to create a vector data set? We have to, okay, so do I have to use an LLM to create the data set? You don't actually have to use an LLM to create a vector data set. You need the embedding model, but you don't need an LLM. And that's why when we talked about how do I generate the vectors, I gave you three different options for that. Sometimes you can just get the vectors from somebody else. That's great. And you can just load them straight into the database. But oftentimes you do need to generate them. And this is where you need an embedding model, but not necessarily an LLM. So embedding services are typically separate from a large language model or an LLM service or a Gen AI service. Or you can simply download the model and run it yourself locally, or import it into the Oracle database and run it in the database itself. So you need an embedding model, but you don't necessarily need an LLM. They're not quite the same thing. So what if I want to create a vectors data? Oh, yeah. Okay, so that was the one we used there. If you've got any other questions, I know my colleagues are over on Twitch. They're answering questions there as well. If you've got anything else, I'm happy to hang around for another minute or two to help you guys understand vectors more if there's any other questions you may have. Otherwise, I hope you enjoyed the session and you were able to learn something new today. And we really do appreciate you joining us. I know everybody's time is super valuable, so thanks so much.
Thanks so much, Maria. While we're waiting for some Q&A to pop in case there's anything else that folks are very curious about, I just wanted to let y'all know that everything that Maria was explaining today in terms of AI vector search, there are challenges that you can participate in. You can find them at the following link. I'm going to go ahead and put that up on the screen for y'all and then also kind of drop it in the chat for everyone that is curious. So go ahead and head over to mlh.link/GHW AIML225 Oracle. I know it's a mouthful, but that's how we like to keep a kind of track of which events links are for which event. So 225, the year and the month, and then also the event. So yeah, head over to that, and you'll see all of the challenges listed there. You'll see the necessary links to participate in those challenges. You'll probably see something regarding the live labs for AI vector search as well. So yeah, it's great resource for you to have. Other resources that you may want to check out if you are new to our basically event format, ghw.mlh.io/schedule. And in the next 2 hours, you'll see that we'll have actually more folks from the Oracle team joining us to talk about additional features on the platform and really cool things you could do with AI and Oracle. So be sure to join us for that session. And yeah, I mean, honestly, like that's pretty much it. You could also check out most of the challenges that we have, the other challenges that we have for the event at ghw.mlh.io/challenges. So yeah, we are, and I just want to call this out. You can check us out on the Ask Oracle channel over on the MLH Discord as well. Bunch of Oracle folk there. They will not tell you the future, but they can tell you the present in terms of how it relates to the question that you're asking. So definitely check us out on Discord as well. And if you have any questions, yeah, now's the time. I think we might be.
I think we're running into lunchtime. I think folks are probably
I think
hungry. Yeah.
I think so. I think so. And I know it's early for you, so
Oh,
I'll let you get kind of
there
out of
is
here.
one
And
quick question about certification, if I can squeeze that
yeah,
one in for these folks.
abs-
There is certification that you can get from Oracle. A lot of it is free, including around vector search. If you go over to oracle.com, I think /certification, or just go to oracle.com and search for certification. You can take certification courses there that will give you the whole proper certification in vectors and AI.
Absolutely. I think I found this one here. It's going to be
Oh,
Oracle
yep,
oracle.com
there you
forward
go.
slash
Thank you.
education. Yeah, no worries. As I mentioned before, I like to go in here and furiously Google search anything that comes up, and it looks like another one of the wonderful Oracle folks in chat have also dropped the certification for AI vector search specifically. So yeah, a lot of great things to come from these sessions. So if you were paying attention, you could get professionally certified in AI vector search through Oracle. So something nice to hang your
Yeah,
hat on.
exactly.
Exactly.
Nice to have. Yeah.
Awesome. So, I mean that's pretty much it, Maria. Once again, thank you so much for your time today. Really
Okay,
appreciate
no
it.
worries.
And for
Happy
the
to be
folks
here.
in chat,
Yeah.
yeah, happy to have you. And for the folks in chat, happy to have you as well. Thanks for answering a lot of those questions. And for everyone else that's in chat right now and watching us from home, make sure to stick around because we will have additional AI ML content coming your way. We've got another workshop right after this. It's not so much about learning how to utilize AI in your projects, but actually utilizing an AI coding assistant and building an application that does so. So check that out with TinyMC. That's coming up. And yeah, we'll see you soon. Thanks so much. We've got a lot of comments coming in terms of compliments. You are
It's always
welcome.
nice to know.
Absolutely.
Thanks, guys. Yeah.
Yeah. Thanks so much again, Maria. And thanks so much to the Oracle team. We'll see you again later.
Cheers. Bye.
Bye.